Today's lesson is on functions, and functions are a specific type of relation. So we're still looking at a set of ordered pairs. Here's the specific definition of a function, which you will definitely have to have this memorized, and you're going to use this definition throughout today's lesson. It says, a function is a relation in which every input, which that represents an x-coordinate, is paired with exactly one output representing a y value. So what that means is if you have the x values 2 and 3, 2 can only pair up with one output. So 2, 4 would represent the point 2, 4. It cannot pair up with more than one. Or 3 maybe pairs up with 5, which would be the point 3, 5. It can only pair up with one output. So in other words, another way of saying the same thing, the same definition, is that no input is ever paired with two or more outputs. So 2 cannot pair up with 2 or more outputs. So this right here would not be possible. Here's a diagram just to signify that a function is a type of relation. So not all relations are functions, but all functions are relations that relate x and y. In today's lesson, we are going to look at relations and then decide if that relation is a function or not. Here we have two new vocabulary words, independent variable and dependent variable. We will come back to these later in the lesson, but you will see them throughout this unit. Independent variable also corresponds to some other words we have already learned. The independent variable corresponds to x values of a relation or a function, which also corresponds to the word domain and the word input. So now let's think about the opposite of an independent variable, dependent variable, and what words would correspond with that. The dependent variable corresponds with y values, which is also considered the range of a relation or function, and the output value. Now we're getting to the part of the lesson where a relation is given and we have to decide, based on the definition, is it a function? So here's the relation, a set of points, and then here's the definition of a function. We're going to decide if by definition this is a function, and we're going to do this by making a mapping diagram. A mapping diagram looks like this. We start with two ovals. One represents our x values, and the other one represents our y values. Two things. We have to first list the numbers least to greatest, and then we have to make sure to not repeat numbers that show up twice within the same variable. So our x variables, or x values, -4, -2, 0, and 1. List them smallest to largest. So -4, -2, 0, and 1. And now list our y values, -3, -2, -1, and -1/2, and list them in order, -3, -2, -1, and -1/2. And now what we do is we pair them up with arrows. The point -4, -3, pair them up with an arrow. -4 matches up with -3, -2 matches up with -2, 0 matches up with -1, and 1 matches up with -1/2. So let's look at the definition. Every input, so every x value, is paired with exactly one output. And if you look here, every input is only paired with one output. So this is a function. Yes, it is a function because each input has exactly one output. So yes, it is a function, and here's our explanation. Make sure you write this explanation down because you will be required to do that later. Here's our second relation, and we're trying to decide, is it a function based on the definition? So let's make another mapping diagram where we have our two ovals, x and y. Let's list our x values. We have 0, 1, 4, and 1 shows up again, but we don't write it twice. So 0, 1, and 4. And then our y values, we have 0, 1, 2, and -1. We have to list them smallest to largest, and -1 is the smallest. And then 0, 1, 2. And now with arrows, we match them up. So we have the point 0, 0. So 0 matches up with 0. The point 1, 1. So 1 matches up with 1. The point 4, 2. And finally the point 1, -1. So let's go back to the definition. Function, every input is paired with exactly one output. Well, if you look at this input of 1, it is paired with two different outputs. Therefore, this is not a function. So our answer is no, this is not a function because the input of 1 matches up with more than one output. So there's our answer. Okay, here's our last example using a mapping diagram. Let's get our x and our y. Our x values, 2, 3, 4, and 5. So in order, and there are no repeats. And then for our y values, we have 5, 4, 5 shows up again, and 6. So let's write 4, 5, 6, only writing the 5 one time. And now use our arrows to match up. We have the point 2, 5, so 2 matches up with 5. 3, 4, 3 matches up with 4. 4, 5, and 5, 6. So let's look at our definition. Every input is paired with exactly one output. Let's see. 2 is paired with 1, 3 is paired with only 1, 4 is only paired with 1, and 5 is only paired with 1. So by definition, this is a function. It gets confusing because if you look here, two different inputs go to the same output, but that is okay based on the definition because each input only has one output. For the next three examples, our goal is the same thing. We're looking at a relation and deciding, is it a function, yes or no? A vertical line test is just another way to determine the same thing. Instead of a mapping diagram, we're looking at a graph. So I'm just going to graph these points first. So -2, -1, -1, 0, over 6 up 3, and -2, +1. So first I'm just going to draw a vertical line through each of these points. And what you're looking for is if this blue vertical line ever crosses more than one point. So this vertical line is good, it only crosses one point. This vertical line is good because it only crosses one point. However, this vertical line crosses 2 points. So what that means is that the input of -2 matches up with two different y values. So it would be like x is -2 and y matches up with 1 and -1. So anytime a vertical line touches the graph or touches 2 points, so touches the graph more than once or goes through 2 points, that means no, it is not a function because it fails the vertical line test. Okay, let's do the same thing. Here's a different relation. Let's plot these points. 6.50 means you're going to go over halfway in between 6 and 7 and up 0. And then over 7 down 1, over 6 up 2, and then over 2 up 6. So here we've graphed the relation. Let's draw a vertical line through each of these points. This vertical line only crosses one point. This vertical line only crosses one point. This vertical line is close, but it still only crosses one point, and same with this last one. They're all very close, but each vertical line only crosses one point. Therefore, because it passes the vertical line test, yes, this is a function. And this last example, you don't have to graph separate points. A graph is given, but we're going to do the same thing. Let's draw a vertical line anywhere on this graph. How many times does our pink vertical line cut through the blue graph? It cuts through this graph twice. Therefore, it fails the vertical line test, and therefore this is not a function. So that is the full lesson on functions, and this definition is what you really need to take out of this lesson. It is a relation in which every input, or x value, is paired with exactly one output, y value. So if you can do that, you can do today's lesson. Good luck!